Hi, I'm James McGuire, and on today's eSpeaks, we're talking about creating machine learning models, specifically a process called feature engineering. To discuss that, I'm joined by Razi Raziuddin, Chief Executive Officer at FeatureByte. Razi, happy Friday to you, and thanks for joining us today.
Well, thanks so much for having me, James. It's great to see you.
So obviously, machine learning models, it's a very hot topic these days. And the idea of feature engineering, we know that the process of transforming raw data into features to train machine learning models is called feature engineering. So big deal, definitely. Why is feature engineering so challenging for companies these days?
Yeah, I think that's a great question, James. I think even before we talk about the challenges, I think it's kind of important to just level set
Good.
on the importance of feature engineering itself.
Let's do it. Let's do a short 101. I totally agree. Let's talk about feature engineering itself. And yeah, for sure.
Right. So the way I tend to think about this is, great AI or great ML starts with great data. So you need a really good data. The better the data is prepared, the better it's managed, the
Right.
better the AI and ML, the modeling outcomes are at the end of the day.
Right.
And so that puts feature engineering, right front and center into literally any enterprise AI and ML effort and initiative out there. Right?
Mm-hmm.
Now coming to why it's really the process of taking raw data that exists in the form of transactions, whether it's banking transactions, credit card transactions, patient visits to hospitals or providers, insurance purchases, you name it. There are all kinds of transactions out there. It's taking all of that raw data and shaping it and putting it in a form that machines and algorithms can understand and learn from and ultimately do predictions on. That process is feature engineering. Right?
So it's really it's about data prep, which is sort of the non-glorious aspect of artificial intelligence and machine learning. People get so excited about AI and ML, but the reality is those things don't exist without troves of data, and not just data, but actually prepared data.
Indeed. And the quality of the data, the quality of how that data is prepared, how it's ultimately managed and deployed, that to a huge degree just dictates the overall sort of performance of the models that get deployed. Right. But since it's such a brutal topic in some ways, it's very conveniently ignored. The sexy part of the machine learning lifecycle is all about building really fantastic models. It's the
Right.
math and the
Tools,
stats,
feature
etc.,
sets.
the tools. But at the end of the day, it's just getting all the data prepared the right way, which is just laborious and it's time intensive. It just chews up this inordinate amounts of time and cycles from data scientists and data engineers. And it's something that it's difficult to talk about because it's the unsexy part of that life cycle.
Right. But the important part for sure. So all right, I think there's a lot of companies out there that are pulling their hair out on this issue. So what advice do you give companies about the best way to prep data for ML models? Is it about having the right tools? Is it about a mindset? Is it data flow? What really matters?
No, absolutely. I think it's a combination of multiple things. I mean, the reason why feature engineering is difficult is it requires a combination of three different skills to come together. You need a lot of domain expertise to understand, okay, well, I have this data. What kind of signals do I need to extract from that data so that I can train models to learn about a particular, let's say, consumer or a product or a transaction, any kind of entity. And then you need data science skills to actually do that, just actually extract the signals from the data. And you need data engineering skills in order to do all of that at scale on really large volumes of transactions and data, right? So bringing all these three skills together, in a single individual, forget about even a team, is just so difficult. I mean, especially in large organizations, these skills live in completely independent teams. They speak very different languages. They use different tools. And a lot of the data management tools that exist today, they're much more sort of built and intended for traditional BI and analytics. They're very useful for descriptive analytics, not so much for predictive analytics.
Aha. Okay.
So it's a combination of just the organizational challenges plus the tooling, I should say the lack of tooling out there.
Right.
that makes the whole process really difficult. So my advice to enterprises is, take this very seriously, because this is really what drives. This is something that, from our perspective, is sort of the last major bottleneck in helping scale AI across enterprises and scale ML. So if you're really looking to do ML at scale, doing really good feature engineering, taking feature engineering management of those features, to heart in some ways, is super, super important. And so, you need to not only sort of bring these three different skill sets together, so that they're speaking similar languages, they understand each other and don't get frustrated with the obvious frictions at the points of interaction between these different skill sets and teams, and look at tools that ultimately make it easy to prepare data, to deploy data. I mean, it's ultimately, if you look at the modern data stack and where data management is today, it's something that's helped a lot of non-data engineers manage and manipulate data on their own very effectively. And you've got analytics engineers, you have BI specialists, you've got analytics specialists. They're able to sort of access data and do analytics in a self-service manner. But that capability in the majority of organizations doesn't exist for data scientists. So there's a heavy reliance from data scientists on data engineers to do the data prep for them. And that back and forth is never efficient.
Can I stop you a little bit? Why is it? Why are those data scientists have so little access to those important tools?
I think it's the lack of tools and also this misperception that data prep is data prep, regardless of whether it's being done for BI or for AI.
Right.
But the requirements for AI are vastly different. I mean, you think about BI, you're creating some metrics for consumption by human beings, or for simple, simple decision making within applications. But when it comes to AI, the kinds of data prep that you're doing, that's the final sort of consumer of that data are algorithms and machines. And so the complexity of the data, the number of data points, the volume of data that you process, all of that is just vastly different. So if you try to apply the BI data prep tools to AI data prep and then deployment and management, it just fails miserably. So it's important for data engineering teams to sort of understand that difference and be able to either acquire or build tools that make self-service data a reality for data scientists.
Interesting. So are you saying that maybe some of the legacy data prep tools are more focused on BI, or are there some great legacy tools that have realized, hey, we're up with the times now, we can do some great prep for AI? Are there legacy tools that also do great data prep for AI and machine learning?
I think there are legacy tools that do data prep, but in a limited way. They're an extension of what I would call where BI stops and AI starts. So they're good for doing some basic experimentation, understanding whether there's a signal that's interesting in a particular data set or data source. But to actually deploy those pipelines in an efficient manner at scale, there aren't a whole lot of tools out there. And so what we've seen, in our experience, both my co-founder and I at DataRobot, as well as just talking to hundreds of clients now, those tools just don't exist. So there's just a lot of bespoke pipelines that get built and deployed by data engineering teams. And it's, you can build a lot of stuff very quickly with all kinds of tools that are available, but to maintain, what's been built, that's bespoke, that's the sort of handcrafted, artisanal, just becomes a huge bottleneck, and the process becomes super brittle.
Makes a lot of sense, for sure. Let's drill down to FeatureByte itself. I mean, how is FeatureByte addressing the feature engineering needs of its client? What makes a difference here?
Yeah, I think the key thing that we're addressing is how we can make the entire process from creation of features to serving features, doing experimentations with features, which data scientists tend to do a lot of, and ultimately managing and governing those features. Super easy and straightforward for data scientists and basically anyone doing modeling and accessing prepared data for AI and ML. So it's really sort of simplifying the entire life cycle is something that we do. And at the end of the day, the way we're going about that is extending the modern data stack to provide the kinds of capabilities and that ultimately are requirements for AI data and for AI data pipelines. And so by doing that, we make the process of sort of helping data engineering teams create a self-service environment for data scientists super easy, and for data scientists themselves to be able to truly sort of create world-class features, state-of-the-art features, and run all of those at scale within the environment, within the data lake or data platform that data already resides in.
Interesting. So it's the self-service piece of that extends the data stack quite a bit.
Absolutely.
Yeah.
And that simplifies the process for data scientists, and then it relieves a lot of data engineers to do other higher value added work within the enterprise,
Right.
instead of being on the beck and call of data scientists who want different cuts of data, who want new pipelines deployed or modifications to existing pipelines. It's a never ending cycle otherwise.
Mm-hmm. Well, I mean, it's an interesting idea that the self-service data skills, data tools, I mean, because it's really about the democratization of machine learning and artificial intelligence. With those self-service tools, more individuals a little bit lower down the skill level or not have more access to data, which brings me to the future. I think this idea of the democratization of data and democratization of AI is going to be a big mega trend going forward. But what is your take? What is the future of data prep and machine learning models as you see it?
No, absolutely. I think unless the data itself is made in is presented in a self-service environment to data scientists, I think that the challenge is going to be for enterprises to really see the potential and the value from AI. There's a lot of promise about creating a predictive enterprise where there are all these decisions that are being made very intelligently. And unless you have the ability to sort of democratize data, democratize machine learning, and have it applied wherever it's needed, there's always the reality, the value derived from AI is always going to be way lower than what the potential is, right?
Mm-hmm.
So this problem just absolutely needs to be solved. And one of the areas, as I described, what we were working on is figuring out how to extend the modern data stack to make things more automated. But the other thing to think about, James, is with the advent of generative AI and large language models. Sorry to bring that up because it's the topic du jour.
Don't apologize. We've got to bring up generative AI. If we don't, like this, it's not even legal to not include it. So thank you, Razi, for bringing that up
in the process, right? But in reality, one of the things that LLMs and generative AI does is it allows the semantics, the domain semantics, to be brought into the platforms a lot more easily and in a much more natural sort of process, right?
Mm-hmm.
So taking domain information, domain knowledge, domain semantics, and embedding that in a platform is sort of what one of the key things that we're working on. That is, as I mentioned, domain semantics is super critical to doing feature engineering, but bringing domain semantics into software, into an application, is super hard. And what LLMs have done is really simplified that, because there's the ability to understand and sort of translate and interpret just a language, plain old English and other languages, and translate that into what's needed by machines, by applications to do their work. Right. So we're that we see as sort of a major factor in both helping create a more automated means of doing feature engineering. It used to be, it still is very hard and laborious.
Right.
Sort of lowering the barriers to that, as well as helping democratize the feature data so that it's not just the domain of specialist data scientists and data engineers, but anyone that understands the data, understands the business, and has the need to doing predictions. They should just be able to use data and be able to access data via a much more simplified interface.
Yeah, that does seem very much like the wave of the future, that ease and simplification. Razi, I think you said it. It's a lot of good stuff. I learned a ton, and thank you so much for sharing your insight today. Please come back and talk with us again sometime. Thank you.
Absolutely. Thank you again for having me, and have a great weekend.